This is Jianhong Zhang from Renmin University of China. I'm glad to share our work, AdarGCN, Adaptive Aggregation GCN for Few-Shot Learning. It is a joint work with Manli Zhang, Zhiwu Lu, and Tao Zhang. Existing few-shot learning methods assume that there exist sufficient training samples from source classes for knowledge transfer to target classes with few training samples. However, this assumption is often invalid, especially when it comes to fine-grained recognition like on CUB dataset, where each class has only 60 samples. In our work, we define a new few-shot learning setting termed scarce source few-shot learning, under which both the source and the target classes have limited training samples. To deal with the scarce source few-shot learning problem, we propose a two-stage framework. In stage A, we crawl sufficient images from the web by searching with the name of each source class. However, the crawled images are always corrupted by a large amount of noise. In stage B, we use our GCN-based label denoising model to clean the crawled web images. And in stage C, with the cleaned web images as well as the original clean training images, we employ our GCN-based few-shot learning model like under the conventional few-shot learning setting. For both the label denoising and the few-shot learning task, a novel adaptive aggregation GCN model is proposed, which differs from existing GCN models in that adaptive aggregation is performed based on a multi-head, multi-level aggregation module. With AdarGCN, how much and how far information carried by each graph node is propagated in the graph structure can be determined automatically. Therefore, alleviating the effects of both noisy samples in label denoising problem and outlying samples in few-shot learning problem, the adaptive aggregation strategy included in our AdarGCN is realized based on a multi-head, multi-level module. In a GCN layer, each head performs aggregation for different iterations, and all the heads are weighted concatenated to update the node future, followed by an edge updating module. Here is the network architecture of AdarGCN. Node future updating is achieved by the adaptive aggregation among the three updating branches C, B, and D with different degrees of aggregation. Branches C, B, and D update the node futures respectively with 0, 1, and 2 iterations, and one iteration update is denoted by a node updating unit which consists of an aggregation module and a multi-layer perception module. Extensive experiments demonstrate the superior performance of our AdarGCN under both the new scarce source few-shot learning and the conventional few-shot learning settings. Thank you for your attention.